Hello, everyone. Welcome. We'll give it a couple minutes and let everyone in, and then we will get started. Thank you all for being here today. All right. Well, it's 1 o'clock, so here we go. Thank you so much for joining us today, and welcome to the Monarch Conservation Webinar Series. Today's webinar is Grasslands Ecology 101, Disturbance Ecology, with Brittany Smith, Habitat Manager at the Monarch Joint Venture, and Logan Shoup, Regional Biologist from Ducks Unlimited. My name is Jenna Tots. I'm the Education Manager at MJV, and I'm joined by my coworker, Katie Lynn Puffer, Education Manager. Before we get started, we just want to quickly thank our sponsor for their support of this webinar series. Our supporting sponsor, Reinvent Your Waste. We appreciate your support so much and dedication to monarch conservation. If you or your company is interested in sponsoring this year, please email learn@monarchjointventure.org. Before we get started, we just got a few community guidelines and hints to help you get the most out of this webinar. If you're joining us today but weren't able to pre-register, go ahead and send that learn@monarchjointventure.org your name, city, and state, and we will get you signed up and get you the follow-up materials. Don't forget that this webinar is recorded. It's going to be posted to the Monarch Joint Venture webinar archive by Friday of this week. The entire Monarch Conservation webinar series archive is free and available to watch. It contains 10 years of amazing monarch conservation webinars. During the webinar, please put all of your questions in the Q&A, which you can find at the bottom of your Zoom screen. We'll collect those for the Q&A session at the end. And please use reactions. You can also find a little reaction button at the bottom of your screen. There we go. Because you're not on screen with our presenters, that's a way that you can interact with them. We want to remind you that there is translated captions on this Zoom call. If you'd like to add captions in a language other than English, click on the arrow on captions at the bottom and be sure the translation button is on, and then choose your caption language. And finally, all of our speakers represent their own viewpoints, which are not necessarily those of the Monarch Joint Venture. And let me introduce our speakers. Brittany Smith provides habitat technical assistance to landowners throughout the Eastern Monarch Central Flyway. Her work focuses on supporting managers of private working lands and regional agriculture stakeholders to create, restore, and sustain pollinator habitat. She received a BS in Fisheries and Wildlife and a master's in Natural Resources Management, both from North Dakota State University. Her career in conservation has taken her all over the Central Flyway, first specializing in wetland ecology and restoration in both private consulting and the USDA NRCS, and more recently with Pheasants Forever and Quail Forever, shifting gears to focus on helping farmers analyze the costs of farming things like wetlands and evaluating habitat conservation program options to improve their bottom line while also protecting those environmentally sensitive acres. She enjoys fishing, hiking, nature photography, and managing specialty crops on her family farm in West Central Minnesota in her spare time. Logan Shoup will also be presenting. He's a regional biologist for Ducks Unlimited, based in Fergus Falls, Minnesota. He focuses on conserving, restoring, and managing wetland, upland, and grassland habitats across Western Minnesota. With extensive experience in private lands conservation, Logan previously worked as a private lands biologist for the Kansas Department of Wildlife and Parks and a partners section biologist with Nebraska Game and Parks. Throughout his career, he has collaborated with landowners, agencies, and conservation organizations to implement habitat restoration projects that support both wildlife and working lands. His expertise in grassland ecology and management helps sustain vital habitats for waterfowl, pollinators, and other prairie-dependent species. So I will stop sharing and I will pass it over to y'all.
Hope I muted. All right, 1 second and I will share my screen. Hypothetically. All right. Are we screen sharing?
That's
good
great.
to go. Awesome. All right, so thank you for that introduction, Jenna. I'm very glad we have you to run through all of the particulars because I am not so well versed in all of our webinar things. But as she said, this is Grasslands Ecology 101. So we're gonna do a little bit of a intro and then a deeper dive into general disturbance and specific types of disturbance important to grassland ecosystems. So welcome. I'm Brittany Smith. I am MJV's Habitat Program Manager, as Jenna said. And I'm going to do our deep dive, or I'm sorry, I'm going to go over our brief intro to grasslands and then do a deep dive into just the basics of disturbance ecology. And then Logan is going to take us home with the specific types of disturbance important to grasslands. So first of all, where and what exactly are grasslands? So this is what a lot of people think of when we say grassland habitat, at least when we talk about grasslands in the US, right? We think about the Great Plains, and the middle of the country are tall grass to short grass prairie systems. But really, grasslands are found worldwide. They're on every continent except Antarctica, and cover about 49% of the total terrestrial surface or land surface of the planet. So what exactly is a grassland? These are some varying definitions, but for our purposes, grasslands are land on which the vegetation is dominated by grasses, grass-like plants, shrubs, and forbs. So we're including shrublands into our definition of grasslands, and also savanna landscapes. So savannas are landscapes with less than 30% tree cover. By contrast, on the other end, we have prairies that have virtually no tree cover at less than 10%. And I like this quote from MDC, the Missouri Department of Conservation. Prairies and savannas often occur alongside each other, one merging gradually with the next. So just thinking about sort of a continuum of that transition zone. And just photos of grasslands from around the world. We have grasslands in Asia, Australia, Africa, South America. The take home here is that grasslands are not just grass. So there are a lot of different plant types in these systems, but it is not just grass. One of the defining features of grasslands, they occur in sort of all areas of the world in terms of climate and precipitation. We have tropical, subtropical, semi-arid grasslands, but the defining feature there is that the precipitation they receive is generally very seasonal, and or they just receive too little precipitation in general. And so there's a long fire season. We have a dry enough period for frequent fire to occur. And keep tree pressure down. So temperature and moisture levels also shape what those plant communities look like on site or in that region. We have cool season versus warm season grasses that'll make up sort of differing percentages of the plant community depending on where you are in the world in response to those temperature and precipitation shifts. And most native grasslands have both, which creates a lot more resiliency in terms of adaptation to climatic fluctuations. And a note about savannas, they are found in generally warmer, hot climates where annual rainfall is about 20 to 50 inches per year. But again, reiterating that rainfall is typically very seasonal. So we have a long dry period where fire occurs. And this is a uniformity map of precipitation across the US. So where it's blue, it's very, very strongly uniform, meaning that we receive sort of an even amount of precipitation throughout the year, trending all the way to, we could look at, the coastal region of California where it's very, very strongly concentrated precipitation. And most of our grasslands are occurring in areas with more seasonal rainfall. Right? So we can examine this commonly held belief, this myth that they say that back before Europeans arrived in North America, the forest was so thick that a squirrel could have traveled from the Atlantic coast all the way to the Mississippi River without ever touching the ground. This is just that. It is a myth. Please stop repeating it. So we are missing a big piece of the puzzle when we say things like that, or buy into that sort of pre-colonial mythology, right? We're missing this Southeast grasslands system. So this is a map from the Southeastern Grasslands Initiative. Really, we had a huge expanse of grasslands throughout the eastern U.S., southeastern U.S. Too far. Added added this overlay here just to show that, you know, to the Atlantic coast, we had grass. And back to this sort of idea of uniformity of rainfall, we can see a lot of overlap and interplay here with our strongly uniform rainfall areas that were likely forested, but the rest was coastal pine savanna, and then we had some southeast interior grasslands in addition to the eastern extent of our tallgrass prairie. This is just a photo of burning in that longleaf pine savanna system. It's very, very fire dependent, fire tolerant. Longleaf pine itself as a seedling or in its initial stage, it just resembles a tuft of grass, and it'll stay that way for years before it actually sends up woody growth. They're very fire adapted. And then throughout the rest of the country, west, we have oak savannas that are a similar system. You know, it's a dotted landscape dominated by these oaks, but with a grassy understory. And different species of oaks throughout the country, but same thing, they're very fire tolerant, fire adapted. And so fire would come through and keep out any other trees or woody encroaching species that would be invading the understory, but the oaks would survive. So let's talk a little bit more about disturbance in general. Ecological disturbance. This is the long, wordy definition, so I apologize, but it is an event or force of non-biological or biological origin that brings about mortality or death to organisms and changes in their spatial patterning in the ecosystems they inhabit. Disturbance plays a significant role in shaping the structure of individual populations and the character of whole ecosystems. So we can thank Britannica for that definition. But what happens without disturbance? Succession. So what do we mean by succession? Are we talking about these people? No. They arguably are also disturbed, but this is what we're talking about when we talk about succession. So primary succession is what happens when we have creation of like a new landmass, so volcanic eruption or tectonic plates sliding apart, colliding, or just exposure of bedrock. So we don't have a soil material at all. Basically, we have the initial colonization of that area by lichens, other microbes, and eventually transitioning into these early, highly adaptable annual plant species and other small mosses, things like that, and continued recruitment of microbes into the soil community. So we actually do start building soil, and then transitioning to grasses, perennials, all the way into your more tree dominated landscapes. But secondary succession is what we're talking about generally when we're talking about grasslands. So we, after a disturbance event, after a fire, flood, any kind of event that sort of clears the landscape, right? We're starting over in terms of the plant community. The difference here is that we already have soil, we have a seed bank, we have living roots in the ground, so we're not really starting from square one. So that's secondary succession. But in grasslands, you know, our climax plant community, because we have such frequent disturbance, relatively frequent fire or grazing events, we are maintaining a climax plant community of grasses and perennials with some shrubs. And this is a map of tree cover change. So it's a GIF. Will take us through 2020 here. We'll let it play a few times. It's just demonstrating the shifts in tree cover across the Western US. So we can see since 1990, tree cover has expanded pretty dramatically throughout most of the West. And here's another example from UNL, focused on the Central Flyway, the Great Plains, but pretty dramatic expansion of trees into particularly the Eastern Plains. And this is another illustration of the same concept. This is from the rangeland analysis platform. I think the thing to focus on with this one is the Eastern US, east of the Mississippi. We can really see this huge difference from 1986 to 2024. do that again. But we have a dramatic increase in just the density and number of trees. And so with that, I will kick it over to Logan to talk a little bit more about our types of disturbance.
Thank you. As mentioned, I'm Logan Shoup. I'm the Western Minnesota Regional Biologist with Ducks Unlimited. Have a lot of extensive experience working in grassland systems, and I'm going to just briefly go over a couple of the major disturbances in grassland ecosystems. There's a whole host of them, but it is primarily driven by two main disturbances: fire and grazing. And I'm going to start off here with fire. So prior to European colonization of North America, fire was frequent and widespread across the continent. Native American cultural burning was widespread and probably the main driver of fire. Lightning strikes did also play a factor from time to time. But that being said, there's been a lot of research into these causes. And a lot of that research has turned up basically in order for fire in pre-colonization times, pre-European colonization times to have been the main driver of fire, we would have to see lightning strikes leading to fire at a rate of 20 times what they do in modern times. And seeing that drastic of an increase in fire from lightning strikes is not reasonable to think. So most of our research and into this basically says that Native Americans were the primary drivers of fire prior to European colonization. So humans have a long history of impacting grassland landscapes in North America. This cultural burning from Native Americans was done for a whole host of different reasons. Some of the common ones: improving ease of passage through forests, encouraging animal grazing of the fresh regrowth following fire so that they could hunt these animals. This one will become important later when we start talking about grazing disturbance. They did it to clear land for crops. They did it to regenerate medicinally and culturally important plant species. They did it to create fire breaks so that they could protect their settlements from wildfire, and a whole host of other reasons as well. There's a really good quote that talks about fire as medicine in Native American culture. I'll go ahead and read it for you. Cultural burning links back to the tribal philosophy of fire as medicine. When you prescribe it, you're getting the right dose to maintain the abundance of productivity of all ecosystem services to support the ecology in your culture. It was really central to a lot of Native American tribes. Because of the frequency of fire, you had very frequent return intervals historically across the US. There's been a lot of research into, what were the there's been a lot of research you're fine into the historical return intervals of fire across the US. And the vast majority of this country burned every acre at least once every 10 years. And then think back to the maps Brittany was showing you earlier of where those grasslands occurred, and it's where the fire occurred largely. There was this frequent low intensity fire due to the cultural practices of Native Americans that promoted these diverse grassland habitats and suppressed the woody vegetation that would convert it into forest land. So there's a wide variety of benefits from these fires. As I mentioned, it kills young woody vegetation, which prevents encroachment into the prairies and long-term conversion of grasslands to forests. It creates varied habitats within those grasslands. It promotes forbs and wildflowers. Directly, as it relates to this, milkweed thrives in the presence of fire. This is from a fire we did in mid-July, and the milkweed came back just even stronger after the fire. And it also increases the forage value of the grasslands, which pull in grazing animals. It helps recycle nutrients back into the soil. It takes this hard locked up carbon that's in, plant matter, and then returns it into forms that it's easily reabsorbed back into the soil. And then lastly, it removes built up fuel, which leads to less intense fire in the future. So in today's grassland, we have a massive fire deficit. What I mean when I say fire deficit is, what is that historic return interval? And then what's our fire return interval now? And that gap is what I refer to as the fire deficit. There's very few places in this country that don't have a fire deficit compared to historical conditions. Historically, a lot of fire laws were created that stifled those cultural burning practices and outlawed traditional fire by Native Americans, which led to these fire deficits and widespread encroachment of woody vegetation into the Great Plains. Today, our fire is mainly practiced by government agencies, some nonprofits, tribes, and then groups of private landowners who want to burn. Wide range of goals go into fire in modern day, but largely it's aimed to preserve, maintain, and improve native grasslands and to reduce fuel loads. So this is kind of looking at some of those big maps Brittany was showing earlier, but just zoomed in so you see what it looks like on a landscape scale. In this, pretty much anywhere that's white is cropland. Everywhere else is, grassland or some sort of native habitats. This is showing over a period of 20 years from 2000 to 2020, the increase in woody vegetation on the landscape. The red is where you see, large blocks of dense woody vegetation, and then the yellow and orange is showing where you're seeing that grassland encroachment. So that's where the grasslands are highly at risk of converting into forest in the future. And in the absence of fire, you lose ground across the landscape. Another thing to mention relating to all this is that grasslands are built for fire. The vast majority of the biomass in the plants in these systems is below ground, and they're nearly all, vegetative herbaceous plants, so that if they get top killed in a fire, that living biomass is below the ground. They'll just resprout and oftentimes be healthier than they were prior to the fire. So, second main disturbance we'll be talking about today is grazing, nature's lawnmower. Historically, all large tracts of grassland had associated large populations of ungulate or hooved grazers. North America was no exception to that. There were bison, elk, pronghorn antelope, two main species of deer that were widespread across the country, as well as prairie dogs. And the populations of these animals migrated across North America following two main things. One, precipitation. So if an area was seeing increased precipitation, producing more forage due to that. And then secondly, fire. When Native Americans were lighting these fires on grasslands, that would pull in grazing animals to those locations. These grazing pressures led to healthy, vigorous, and diverse prairies across North America. A couple of historic range maps, just so you get the idea of the breadth of grazing animals historically in North America. This is the historical range of bison in North America. They cover nearly all the historical grasslands of this continent, and even into many of the woodlands as well. And they were a major factor. Elk were another big one, like I mentioned. Their range was much the same as the bison, and they were another major grazer. Pronghorn antelope, not quite as widespread, but still a major player. And then the last one here is prairie dogs. The orange line is kind of the extent of their historical range. And without getting too much into the science of this map, more or less most of the prairie dogs we find currently are in those red areas. So vastly reduced range from where we'd see prairie dogs historically. So historically, this grazing led to a whole host of effects and benefits for the prairie. One of the biggest ones is that the hoof action and selective grazing promotes a diversity in vegetation structure and species composition. As you can see, especially on that right picture there, you can see where they're opening up that habitat at the ground level, allowing those forbs, those wildflowers to flourish, and really improving that grassland. And I will also mention, I have way more pictures of cows grazing than I have bison, because we have a lot more cows nowadays than we have bison. So just a quick note. That being said, the next one is bison. Fire and grazing historically had this massive intersection of effects on the landscape. These grazers followed the fire because fire led to a highly palatable forage. And this grazing following the fire, it had a cumulative effect greater than just the sum of the parts. It suppressed woody vegetation and then increased that diversity. And these grazing regimes were very closely tied to the fire regimes. And I'd like to point out this one. You can see the bison on this freshly burned landscape. I've worked on this ranch before, and these bison have access to unburned pasture, and yet they're on the stuff that was burned in the past week or two. It's that high value for them. Additionally, these natural cycles of high intensity, short duration grazing led to a maintenance of healthy, diverse grassland and a stimulation of the vigorous growth of those grasslands. And I want to point out that when I'm talking high intensity, short duration in this context, in a historical context, that is independent of what I would say when I'm in a agricultural context. They're very different things. In a historical context, you'd be looking at, rest times of sometimes years between heavy grazing events. These grazing animals naturally moved across the Great Plains regularly, and they migrated, they followed precipitation patterns and fires, so they were not just, hitting the same spot heavily 3 times through the same year or something like that. Additionally, this natural grazing, it increased the nutrient cycling of the prairies. Which built a rich, healthy soil system by converting that plant matter back into nutrients such as carbon, nitrogen, and phosphorus, which also led to an increase in the carbon sequestration ability of these prairies. The last point I'd like to make about grazing in a historical context is that the grazing increased the biodiversity due to it increased the biodiversity due to plant diversity increasing, but also a huge number of animal species were tied to this grazing regime. Things like prairie dogs, burrowing owls, dung beetles, and then a wide variety of insectivorous songbirds were all tied to these grazing regimes. So what does modern grazing look like in grasslands? It's primarily cattle grazing. I will point out cattle graze differently than bison, so it's not a 1-to-1, and it never will be unless you have a vast landscape you get to work in with bison and other native grazers. But that being said, across much of the United States, cattle grazing is closely tied to native grasslands. And while the species, rest times, grazing intensity often doesn't match our historical regimes, it still helps to maintain existing prairie systems. And even though these systems don't perfectly match historical grazing patterns, many ranchers and cattle producers are moving towards some higher rotation, longer rest systems, systems where they can more closely mimic some of the natural processes and learning ways which they can graze, in a way that not only is profitable for them, but maintains some really healthy, diverse native prairie. And these systems oftentimes lead to healthier, diverse grasslands. So to kind of recap disturbance, what happens without it? The natural succession cycle leads to woody plant encroachment and eventual conversion into forest. We see a loss of plant diversity due to the dominance of a few competitive species. We see reduced habitat quality for grassland-dependent wildlife, and then our soil health and carbon storage potential declines. With that, I'll hand it back over to Brittany to kind of wrap things up and show a little bit about what this means in terms of habitat loss for a lot of our prairie species.
Sure. So I see some good questions in the chat that we can kind of, I think, address as we talk through this too. So yeah, I think we want to reiterate that it's not just conversion of grasslands to agricultural land uses or urban development, suburban development, basically human land uses, right? It's habitat quality decline due to a lack of active management. So even where we do have habitat, we're seeing impacts to grassland dependent species because we are not actively managing these habitats in the way that they had been historically managed by people. To reiterate that it is, again, largely people driven. And so for things like the monarch butterfly here, we've all seen these population charts, graphs. We see the trend lines overarchingly going down. It's the perfect storm. It's not necessarily one thing, any one thing that's causing these declines. It's the combination of things. So yes, habitat loss, loss of grassland habitat in general, absolutely a driving factor, but we also have to start to think more intentionally about habitat management as an active practice and not a passive one. I think people tend to think we protected a parcel of land, that's enough, right? It's not able to be developed anymore or farmed anymore or what have you. That's good enough, right? Nature will take care of itself, but nature has never taken care of itself per se. We were nature, we are part of nature, and humans were the ones driving a lot of this disturbance in North America and beyond. So indigenous burning was common practice throughout the world, it still is. It's making a comeback in Australia, for instance. Other places we're really recognizing that we have to start picking up the pace with respect to fire and active management. And so these are some other charts. This was from the previous State of the Birds report. So there was a new one that just came out. This is from 2022, but the trend lines are essentially the same for our grassland birds, also declining, just like the monarch. And sorry, Logan, I apologize for my intermittent clicking before. My thing doesn't like me either.
Fine.
This is one of my favorite examples. This is a chestnut collared longspur. Historically, they would follow heavy grazing and fire. They really like that sort of short, disturbed grassland habitat, but in a more tall grass to mixed grass prairie setting. They're not like a short grass prairie bird per se. They're on the eastern edge of the Great Plains, but where we don't see that anymore. Now, the chestnut collared longspur has declined by about 84% since we started doing breeding bird surveys in the 1960s. So this is extremely substantial. And it's just one of many. There are others, mountain plover, thick-billed longspur, similar things, especially where we had sort of these compounding interactions like Logan was talking about between fire and grazing, thick-billed longspur, mountain plover. We saw utilizing like prairie dog habitats where there was also bison grazing and fire. So like this really, really short grassland habitat maintained by a lot of things actively working together. And we don't really have that anymore. So I'm going to go ahead and share. We shared a video after this slide, so I'll share that and then we'll come back to questions. This is from our partners at Pheasants Forever and Quail Forever in Kansas. And I just really like this demonstration of sort of what woody encroachment looks like for a lot of the Great Plains. And it might look a little different in the East, but this is a good illustration.
Brittany, is there supposed to be sound?
Oh, is there not?
No, you might have to go in and share your sound. in your sharing settings.
We'll just leave it and people can replay it we'll make sure sound works, or we'll link it.
I think it was mostly just music anyway.
Mostly
right?
it's a visual.
Yeah.
Yeah, it's for the visual sake. And it's talking about a program that I'm not sure what the funding status is of this program, but the visuals still apply, and we have other potential funding sources that can help facilitate this woody encroachment work. And so yeah, we just wanted to sort of share that visual. And I think that's another thing we didn't really talk about was the economic repercussions of woody encroachment and just lack of grassland management, because it's a big blow to forage production for grazing systems. So it's a concern to farmers and ranchers for sure. So with that, we'll go back to questions. I see we have plenty.
There are plenty. Thank you both so much for your presentation. You are both a wealth of knowledge. And I know in the practice session, you both said you could present for hours. So we'll start back. These questions were during Logan's presentation, but I know both of you are very well versed here. Can you please speak more to the benefits of fire releasing nutrients in the soil? The first thing that comes to mind for me is sending excess amounts of carbon into the atmosphere.
It's a big one and a complex one. You do release carbon when you're burning. That's just a fact of how it works. That being said, it was a natural process in grassland regions. It was something that existed to maintain these regions prior to European settlement of these areas. And additionally, grasslands have been shown to be one of the most resilient ecosystems to loss of carbon storage, because Brittany's going back up to the slide, because of that. It stores the vast majority of its carbon underground. And once that starts to convert to a forest system, that carbon is being stored above ground. And so if you get a wildfire go through a grassland system, you're losing some carbon, but you're not losing probably even 10% of that grassland system's carbon. Whereas if it goes through a forest system's carbon, you're losing a huge amount. So you are releasing some carbon when you're doing prescribed fire, but you're helping that system maintain its carbon resiliency long term. And do you have anything you want to add to that, Brittany?
Yeah, just that this is why we talk about grasslands being a more reliable carbon sink than forests, because forests have the ability to store a lot of carbon, but there's a huge risk when it comes to fire. So when we do have a wildfire come through and, actually kill trees, like you're getting at, all of that carbon is released to the atmosphere. So when the bulk of our biomass, 60% plus of our biomass, is below ground, it's a much more reliable sink.
Thank you. That was beautifully said, both of you. Has there been an increase in rainfall, especially with climate change, that contributed significantly to the increase in trees in the southeastern and central US?
That's a great question. And yes, it depends on where you are in the US. I did a master's on essentially climate change in the prairie pothole region, offsetting impacts of climate change. And the climate models from 20 years ago have largely held true for the middle of the country, where we see a steepening of this moisture gradient. So the western extent, the western edges are getting drier, the eastern edges are getting wetter. So there is a natural shift to favor a more heavily treed landscape in that scenario. But we still see really seasonal rainfall. And so we're seeing this increase in seasonality as well, not increase, but just extremity of our spring and fall rainfall events. So we're still receiving the bulk of our precipitation on the bumper season end. We're experiencing still that really dry fire season. So it's not to say we can't and shouldn't manage like we would have managed historically, because we have the opportunity to do that, for what it's worth, from my perspective.
Thank you. Can grassland habitat be managed well in an urban setting in the absence of fire? And I'll just add to that. Or can you use fire in the urban setting to manage grasslands?
Ask your fire department first, or you just go.
The
Thank
short
you.
answer is yes and yes, I would say.
Logan's just gonna go do it. Don't take his advice.
Don't tempt me. There's actually some really good spots that are starting to do prescribed fire in more urban landscapes. It takes way more coordination. You know, when I'm working with a rancher out, like I used to say out in Western Kansas, you know, where he has 3 neighbors and you're 20 miles of the nearest town, it's a lot easier to coordinate that than when you're lighting up, you know, 15 acres in the middle of a city. There has to be a much bigger education component, a much bigger outreach component, so that people know what you're doing and why you're doing it. But one of the cool areas like Fontenelle Forest in Omaha has been starting to do a lot of prescribed fire, and they're like right on the edge of Omaha. So it is being done. I'm sure there's others. That's the one I'm mainly aware of. But it definitely can be done. You just have to go through some more steps. And in the absence of fire, there are other options. None of them quite are as good as fire, but there are some other options. Haying, bringing in small herds of grazers, things like that.
Mowing. I mean, if we're talking a really small, like I'm a backyard gardener, granted,
Yeah.
they make lawn torches. Again, call your fire department. Don't just do it. But mowing is an option, you know, trying to mimic grazing a little bit there, you know, managing that sort of biomass load like grazers would have. We can strategically mow at times of year to like most hit grasses. Grasses are what takes over. Again, in the absence of fire, we didn't really talk about shifting of plant community dynamics, since this was kind of intro to disturbance in grazing or disturbance in grassland settings. But that's another thing that happens in the absence of disturbance, is we see grasses really heavily take over. And so we lose that forb component, the wildflower component that supports our pollinators, that supports those insectivorous birds, right? And so that's another factor in addition to woody encroachment that we see for habitat quality decline. But yeah, we can mow strategically to kind of time it to most setback, most injure those grasses to help your wildflowers come through. Yeah.
And I would say if you're doing it and have the ability to actually hay it, I would prefer that over mowing, because when you're mowing, you're basically creating a layer of mulch that can hamper some of your wildflowers. So it's not the end of the world if you can only mow, but if you have the ability to hay and get that thatch off of there, it's beneficial.
And
Or
for
just
a
bag up. Yeah.
for a non-habitat person, the difference being leaving that there for and then for taking it off.
Yes.
Okay.
Yeah.
Right. Thinking about a yard, just like, you know, leave the bag on your mower and take the clippings elsewhere. Yeah.
Okay. Great. That answered, is haying a good management tool in replacement to the fire? So thank you very much for that. Let's see.
Also go into a whole deep dive on haying.
And we will add a bunch of links to some PDFs that MJV has created on some of these other techniques in the follow-up email that will go out on Friday. So what type of tree species are encroaching? Are they mainly invasives?
No, in terms, it depends on where you are in the country. In the middle of the country, like we were talking about eastern red cedar, I think quite a bit, or like the video was showing that's eastern red cedar encroachment by and large. But yeah, it depends on where you are in the country. Rocky Mountain juniper is problematic. Red-berried juniper is problematic. There are all kinds, tree mesquite. It depends on calorie pear can be quite problematic. That is an invasive, but a lot of them are native species that just in the absence of disturbance, like they're the first things that come in. You know, let's think back to this slide about succession. I can go back to that slide. But we have these sort of early successional trees, and a lot of the trees that we see becoming problematic fit that bill of things that show up right away in terms of woody species. So without disturbance, we're just favoring those species very heavily.
And I would also add that things like, say, yes, eastern red cedar is technically native across much of the range that it's invading into. But it's becoming to, it's getting to the point it's showing up at a vastly increased rate from what you would natively see. And the trees themselves are very different from the native trees you'd find with, at least with the case of eastern red cedar, because we were so effective at breeding them to be faster growing, denser growing, and reproducing faster because we bred them to be good windbreak trees. And so where we see them invading, oftentimes it isn't even the same, the same tree that you would see natively growing, more or less.
Yeah, thank you. Devil's advocate question for you. And I just want to preface, this person wrote, I love the prairie. I hope it can be saved. But here's the devil's advocate question. Does it even make sense to fight against this seemingly natural process?
As a prairie advocate, I understand. So this is the counterpoint that we get all the time, right? Like we hear this, well, it's a result of natural processes. Why would we spend money or time to intervene? And again, I go back to, well, we removed the natural process that was here for thousands of years in terms of fire. So the people who were doing fire, we didn't allow them to do fire, and we have actively been suppressing fire for 150, 200 years now. And so, is it natural if we consider the human aspect, the anthropogenic addition to what created this environment? I don't think that it is fully. We have to appreciate our role historically, but also we have thousands, hundreds, if not thousands of species when we factor in inverts, birds, mammals, plant species that are adapted to this environment. So do we just let them go extinct? Is that the moral and ethical thing to do when we can just light a fire every now and then and still get to enjoy those prairie endemic species?
Beautiful answer. I'm going to ask this one because we've talked about this internally at MJV. Historically, milkweeds were removed from cattle pasture because of their toxicity. Can you address this clash between grazing and monarchs, or potentially not clash?
Yeah, that's a great question. And it is another one that we get all the time. So there's recent research that has been done looking at forbs more broadly. We'll start with milkweed, but Chris Helzer in Nebraska, who is credited for many of our beautiful grazing photos, he and some folks from UNL, I believe, undertook a study in sort of the Sandhills region of Nebraska looking at cattle grazing preferences in that sort of tall grass prairie environment. And they found that cattle preferentially grazed common and showy milkweed as often as they selected for our major prairie grasses. So basically cattle, and those of us who graze cattle, so we have cows. I have some nice fence live photos that show that they'll graze it right on out. It's an ice cream plant. They'll select for milkweed, actually. And as long as it's not like the only thing that they have to eat, which is another, issue that we can address, like that's a grazing management problem probably versus a, milkweed problem. If they're eating it at high enough levels to induce toxicity, that's because they don't have anything else to eat. But yes, really interesting, showing just like the cattle preferences for milkweed, but also like forbs more broadly. Xerxes and NRCS have been undergoing a forb nutrition study in the upper Midwest and looking at just nutrition of various wildflowers over the season. And it's broadly, they are as nutritious as grasses or more in a lot of cases as grasses. So it's a really interesting thing that we've always focused historically on grass for animal science, but we've overlooked the forb component.
Yep. I would also add to that, especially if you have fire in the system as well, those fresh milkweed shoots after fire are incredibly highly palatable to cattle. And yeah, like Brittany said, you generally only have problems with milkweed toxicity in incredibly overgrazed systems where they don't have anything else to graze. So,
And to that point, that Helzer study, it was in a prescribed, like a patch burn system. And so they looked at the grazing was the control. So in the grazing system, that's when the milkweed started to disappear or was impacted and not fire. So we can demonstrate that cattle are selecting for milkweed.
What is the reason for livestock preferring recently burned areas for grazing while having access to those non-burned vegetative areas?
so what it does is it basically removes all the existing growth on the plants. If it's a dormant season burn, all that existing growth is all senesced vegetation or dead vegetation. Dead vegetation doesn't have nearly as high of protein levels, nutrient rates, things like that. And so then when those plants start regrowing, that's all new, fresh vegetation that's much higher in your crude protein levels, much higher in all your micronutrient levels. And so it's much more attractive to grazers. That's it in a real nutshell, but hopefully that.
Yeah, and even if it's not dead vegetation, that older vegetation has more things like lignin
Yeah.
or other things that aren't as tasty.
Yep.
How are the grasslands doing with persistent droughts? This person said they lived in central Texas for almost 4 decades. Droughts and insane heat is much longer, and any plant that could emerge was hit hard by grazers.
That's another very good question, and one that they've recently been looking at in terms of global study, because we've long thought that grasslands were just sort of like this infinitely resilient system in the face of drought because we have these natural, wet and dry cycles throughout most of our grassland ranges. But it turns out that drought really, really negatively long-term, especially the type of drought that we're talking about here in Texas, like long-term impacts from that are pretty significant in terms of negative impacts on carbon storage and plant diversity and all of the good things that we like to see. So long-term drought as a result of climate change is something we are concerned about.
Yep. And where that interacts with grazers, it's not an easy question, because you're talking a lot of times about folks who have very established operations that their margins and their financials are built upon grazing rate they've had for decades sometimes. And so it involves some level of change a lot of times in those systems where they're looking at building drought plans or altering their grazing plans. And so it's not an easy question, but there are a lot of biologists who are actually whole job is to look at those types of situations.
Okay. This person's in the Southeast. How often would you recommend burning a smaller area, less than 5 acres, that's been designated as a pollinator plot using an old field management strategy? It says we're trying to bring back native vegetation and are looking for recommendations before we receive funding for native species planting.
Where in the Southeast exactly? I mean, it's going to be sort of locally appropriate. Generally, we say 3 to 5 years is a broad recommendation, but depending on where you are, we could fine tune that.
Yeah, the 3 to 5 years is kind of the standard, I guess, but it does depend on your goals, your location, how well your grasses do in that system, and how aggressive they are. What time of year you burn can affect that as well. So there's a lot of variables, but generally 3 to 5 years is a good rule of thumb.
Great. If that person wants to email me, I can get their information over to Brittany and Logan and get a little bit more information.
Habitat at MJV, Habitat at Monarch Joint Venture. We have a habitat help desk, and our folks can get you a local answer.
We will include that in our follow-up as well. I know Brittany and I presume Logan are bird people as well, so we'll do this one. What are tipping point species? Bird species.
Tipping point species are those that are critically dependent on grasslands, and so we're reaching a tipping point for those species. Like, we're very concerned about their population levels.
Are there some that are at that point now, like specific named species?
I have to look at the latest and greatest state of the birds report. But you know, basically all the ones I mentioned are of concern. And then actually I do know that in the latest state of the birds report from 2025, more eastern species are also called out as being of greater concern than in previous reports. Things that were, you know, we talked about chestnut collar longspur and thick-billed longspur and mountain plover that are really sort of these very specialized species, but we have others like just western meadowlark that have decreased so substantially. Eastern meadowlark has decreased even more substantially. Lark bunting, lark sparrow, lacan sparrow, all these little brown birds that really they really rely on these very, you know, specialized
One
grassland
thing-
systems don't exist anymore. So
One thing I'd like to add too, that, you know, you normally think of the grassland species and as being these highly, you know, grassland dependent species that follow tipping points with that, but also in, you know, the duck world where I come from, the same thing applies because a lot of waterfowl are grassland nesting species, and some, you know, say northern pintails are highly preferentially select for early successional vegetation for their nesting cover. And so when you lose that early successional vegetation on the landscape, the population goes into a nosedive, which we've been seeing with northern pintail. So it's not just your upland species that you think about.
I
yeah,
mean, not
and
great, but thank you.
with
for
with
your
that,
answer.
I mean, ducks, it was in this last state of the birds, ducks
Yep.
were also noted as being on the decline on the whole,
Yep.
which is sort of a first. We've had a pretty good recovery since the inception of NACA and these wetland protections. So
Yep.
Well, thank you both so much for your time, for your expertise. We really appreciate it. Again, this was recorded and we will put this up on our archive page. I just want to throw the feedback form in the chat. If you could just click on that, just a few short questions about your feedback on the presentation. And then a couple of things coming up. We'd like to invite you to our first of 2 Monarch Conservation webinar mini series in Spanish. So we have 2 this year. The first one, presented entirely in Spanish, will be on Thursday, April 10th at 1:00 p.m. Said the other one's in October. I'll put the registration link in there. This is different from this webinar registration. So if you're interested in that, please follow that one. That first presentation will be titled Win Monarca, the Role of Women in Conservation, presented by Elizabeth Espinoza Hernandez, co-founder and administrative coordinator of Ambiamos Actions and Adaptive Responses. And then back to our originally scheduled program with this webinar series. Our next webinar will be on Tuesday, April 22nd. That will be titled Getting Youth Involved with Monarchs. It's kind of a 2-part on youth, this one in April and the next one in May. That will be actually presented by youth. The Getting Youth Involved in Monarchs is with Susan Myers. She's a volunteer for Monarchs Across Georgia, Committee of the Environmental Education Alliance. And then Alejandra Vieira, Jessica Hernandez Geronimo, and Tatiana Sanchez Rodriguez of Papalome. And so they will be doing their presentation in April. So again, thank you so much, both of you, for your presentation. And thank you everyone for participating today. Everyone have a great day.